we have an active circuit and we have two sources, a current source and a voltage source, and they are extracted from the resistive part, and our task is to find this voltage across the current source if a value of this current source is doubled. We know measurements of this voltage for two different combinations of values of these two sources. Then actually our task is to find the transfer functions, or more precisely to find components of this voltage, component which is the effect of this current source, and the second component as the effect of this voltage source. In general, if we have multiple input, single output system, or eventually multiple input, multiple output system, which means we have m inputs, m sources, and one or n outputs, and this system is described by m in case of single output or mn transfer functions. And to identify these functions, a measurement of the output or outputs in MIMO system should be performed for m linearly independent sets of inputs. So we need two measurements. We have them. In our case, this is a block diagram that describes our problem. We have two transfer functions. We have two components of our voltage. The first component is the result of acting a voltage source, and the second component is a component that is the effect of acting a current source. Then we may take into account that we have these two measurements to calculate actually not transfer functions but components of the voltage U. The first component, a component which results from J, is 5, and the second component from E is 10. Then voltage is 15 volt. The total voltage is 15 volt. As sum of these two components, please observe that nominal values of these sources are not given, which means that it is impossible to designate these transfer functions, but we can designate individual components of the output, this component and the other component. Now, if source J is doubled, E is unchanged, then this component remains 10 and the second component is doubled. Then a voltage across this current source is unchanged, 10 volt plus 2 times 5, as J is doubled, which gives 20 volt, and this is answer to this problem.